Think about a telescope powerful enough to look back in time. Not in the science fiction sense of time travel, but literally looking at light that has traveled billions of years to get here. That's what the James Webb Space Telescope is doing today. It's not merely showing us gorgeous pictures of the universe, it's rewriting all of our history on how everything started. But then, something unusual happened recently. Webb picked up a huge, dark emptiness, something scientists didn't anticipate whatsoever. This is not another black hole or hollow space between galaxies. This is something much more enigmatic. The emptiness that Webb has identified is so distant that light from it took more than 13 billion years to travel to us. That means what we're seeing happened not long after the Big Bang, so early in cosmic history that galaxies were only just beginning to form. But here's the twist. This void appears to be too large, too empty, and too cold to match anything in our current cosmological models. It's like staring into a hole in the fabric of the universe itself. Of course, this has sent a shockwave through the astrophysics world. What would lead to such a huge lack of matter and energy? To get an idea of how strange this finding is, let's take a step back. As per the Big Bang theory, the universe started as a very hot, dense point some 13.8 billion years ago. It expanded very quickly in a process called cosmic inflation. As it cooled down, matter collided under gravity and formed stars, galaxies, and all the things we are familiar with. Time passed, and these galaxies broke apart, taking with them super-large structures, filaments of galaxies divided by voids in empty space. These voids are the rule. But Webb has discovered that what it contains is much, much more than a standard cosmic void. This enigmatic area is close to what astronomers refer to as the cosmic dawn, the era when the earliest stars and galaxies were illuminating the universe. At that time, the universe remained largely dark and full of neutral hydrogen gas. The James Webb Space Telescope was particularly developed to research this period since its infrared detectors are capable of measuring weak, redshifted light from those distant periods. And that's just what it was doing when it ran across the surprise structure, a huge region that contained no galaxies, stars, or even the normal background radiation. The more researchers examined the data, the weirder things became. Early on, astronomers suspected the dark region could be due to some kind of instrumental error or data corruption. After all, the Webb telescope is a new toy, and researchers are figuring out how to translate its complicated readings. But after double-checking and triple-checking the data, properly calibrating the sensors, and double-checking again against other telescopes, they eliminated the chance of error. This emptiness was genuine. And it was huge, hundreds of millions of light-years wide. That's not merely an area of space with fewer galaxies. That's an entire cosmic region that seems almost untouched by matter or energy. To put that into perspective, imagine flying across the United States and seeing that everything, cities, towns, highways, has suddenly vanished for a span as wide as the entire country. No people, no buildings, no roads, just emptiness. That's what astronomers are seeing on a cosmic scale. But what this emptiness is so frightening about is that it goes against all that we understood of the topology of the ancient universe. Matter, in every Big Bang-based simulation, must be fairly homogeneously dispersed initially. In the course of time, it becomes clumpy to create galaxies and stars, but there needs to be nothing such as wide expanses of clean emptiness so early on in history. One theory that is gaining momentum is that this void may not be a void, but actually proof of a systemic flaw in the way we interpret the early universe. What if cosmic inflation didn't occur exactly as we have imagined? Or worse, what if the Big Bang model itself is flawed? These are provocative questions, but that's precisely what science calls for in the presence of new evidence. The Webb telescope is not just confirming old ideas, it's challenging them. And this latest finding may be the biggest challenge yet to our understanding of the cosmos. Another hypothesis proposes that this void might be a sign of some exotic phenomenon, perhaps dark energy or dark matter behaving in ways we've never observed before. Scientists are aware that dark matter constitutes approximately 27% of the universe and dark energy 68%, but both are total mysteries as far as their composition is concerned. Perhaps, in this specific area, dark energy held back galaxy formation. Perhaps some unusual type of dark matter inhibited the normal gravitational clumping that results in galaxy formation. If so, it would transform the entire branch of cosmology. Another concept under investigation is that this might be the signature of a cosmic bubble, a region of space created during inflation that became cut off in some way from the rest of the universe. This idea follows from the theory of eternal inflation, in which our universe is one bubble in a sea of bubbles in a multiverse. In such a scenario, some bubbles might crash into each other while others might be separated. This emptiness might be the boundary of such a bubble, a region where the laws of physics are slightly different. It sounds like science fiction, but top physicists are taking the idea seriously. And if that weren't crazy enough, some have speculated that this weird zone might be a scar on the fabric of space left over from a giant cosmic collision, maybe even the trace of another universe bumping up against our own. There are theoretical models of physics in which universe-to-universe collisions are possible, particularly at the earliest times during cosmic inflation. Another universe, which temporarily collided with our own, might have left behind a signature, a cold, empty void, in which matter was pushed aside. These models are speculative but do predict structures that appear disturbingly similar to what Webb saw. Needless to say, not everyone is quite so eager to dump the Big Bang Theory or embrace the multiverse. Most scientists feel that more information is required before making such revolutionary declarations. The Webb telescope is at the beginning of its mission, and each week surprises us in some way. Future observations of the region will include more thorough scans and spectroscopy to see if there are low-level objects or gas clouds that we overlooked in the first place. But even if this void is found to be explainable under existing models, the fact that we can now see such phenomena in this level of detail is astonishing in itself. It also raises larger philosophical questions. If such voids exist, and if they are much more common than we thought, what does that tell us about the nature of the universe? May we be living inside a cosmic glitch, a temporary pool of space that just happened to provide the means for life, and the rest of the universe remains quiet and void? It is called the anthropic principle, and it is very distressing. That it implies we do not actually live in a finely tuned universe but simply where we happen to be in the limited areas which make life achievable. And everywhere else might be empty, black, and frigid. And then there is the even more chilling possibility that this emptiness is growing. If so, we might be seeing a new type of cosmic evolution. One in which dark energy or some other agent is devouring patches of space and rendering them dead zones. Just imagine a world in which galaxies disappear into thin air, not because of the passing of time, but because some kind of bizarre phenomenon is deleting them from the universe. That's the sort of thing that keeps astrophysicists awake at night. And yet, as sensationalistic as it sounds, we know that the universe tends not to do what it's supposed to. The universe has a history of surprise. This finding also underscores the awesome capability of the James Webb Space Telescope. It's not simply a Hubble replacement, it's an entirely new type of observatory. Because it observes in the infrared spectrum, Webb is able to perceive what was otherwise invisible to us. It can look behind the dust clouds, see the faintest glow of heat, and gather light from the most distant objects in the universe. And with each picture it sends back, we are reminded that the universe is a lot more complicated and mysterious than we ever dreamed. Every discovery leads to 10 more questions. And that's precisely what makes science so thrilling. The emptiness at the edge of time, as some have begun referring to it, could be the key to unlocking new physics. It could instruct us in the boundaries of our models, or perhaps reveal something completely different. It could vindicate centuries-old speculation about dark energy. Or maybe, possibly, it will lead us to confront that everything we thought we understood regarding the beginning of the universe needs to be rewritten. Regardless of what's found, one thing is clear. This find is a milestone in our understanding of the universe. And it's just the start. But here's the kicker. This isn't the first void the James Webb Space Telescope has encountered. As stunning as this specific dark area at the boundary of the observable universe is, astronomers have begun to notice smaller, similar anomalies peppered throughout Webb's initial data. Not all of them are so gargantuan or sensational, but their trend is raising eyebrows. Is this part of a greater cosmic formation we have never witnessed before? Or are we only now beginning to discover that the universe is much stranger, patchier, and more capricious than we've ever dreamed? Indeed, some researchers are even comparing this unknown void to a phenomenon called the cold spot. That's an area in the cosmic microwave background, the Big Bang's afterglow, troubling scientists for years with its cooler-than-expected temperature. Some have speculated that it might be the signature of a giant supervoid. Others postulate it might be proof of a parallel universe colliding with our own during the early moments following the Big Bang. Webb's new void discovery is now being compared to that cold spot, and some are beginning to wonder if they're somehow connected. This connection, if it exists, could open the door to an entirely new branch of physics. We've always assumed that the universe expanded smoothly after the Big Bang, but what if that expansion was uneven? Suppose some regions expanded more or were governed by forces yet unknown to us. Picture cosmic weather patterns, wide expanses of space controlled by unseen forces that dictated the geometry of all. That's the sort of perspective scientists are now being made to contemplate. And it's no longer conjecture. Now we have physical evidence, pictures, and measurements that indicate something real, something inexplicable. Even within the scientific establishment, responses have varied from hesitantly intrigued to outright excitement. Some researchers are labeling it one of the most important celestial discoveries of the decade. Others are more muted, stating that we need further data before asserting anything dramatic. But everyone concurs on one thing: the James Webb Space Telescope has opened a window into the early universe that we never had before, and what we're looking at coming through that window doesn't fit the textbook. And that discrepancy is precisely where revolutions in science take place. History has taught us this again and again. When Galileo first pointed his telescope at the heavens and saw moons orbiting Jupiter, it shattered the idea that everything revolved around the Earth. When Edwin Hubble discovered that galaxies were moving away from us, it confirmed the universe was expanding. And now, with Webb, we're facing a similar turning point. A huge, ancient emptiness where there ought to be light and order might be our generation's equivalent of those ancient milestones. What's more intriguing is that this emptiness not only defies our picture of the early universe, it challenges our future too. If there are such irregularities at the boundary of space and time, what else lies beyond our horizon of observation? Are there areas of the universe so fundamentally alien that our physics just doesn't work there? Are there whole cosmic sectors governed by different laws of gravity, time, and energy? These aren't fantasies of speculative science fiction anymore. These are questions being posed in leading astrophysics departments across the globe. And then there's the issue of life. If such voids are real and widespread, what does that mean for the potential of life elsewhere in the cosmos? We've always based the search for extraterrestrial life on the assumption that the universe is more or less uniform, that the same laws of physics and chemistry apply everywhere. But if these vast lifeless zones exist, then maybe habitable regions like ours are extremely rare. Perhaps we aren't alone by chance, but due to the fact that the universe is inherently biased towards being empty. This concept smacks, because it's not so much about discovering aliens anymore, it's about where we fit into the grand scheme. Are we a cosmic accident? A small flicker of consciousness drifting in an ocean of void that goes on indefinitely in all directions? The discovery of the void forces us to think about questions that go far beyond science. It touches philosophy, theology, and the deepest parts of human curiosity. We've always wanted to believe the universe is full of wonders waiting to be discovered. But what if, instead, it's mostly silent, mostly empty? Even more chilling is a new theory gaining momentum. Some researchers believe this void may be growing. It's subtle, and we don't have decades' worth of Webb data yet, but initial comparisons indicate the dark region is spreading outward. Gradually, steadily, devouring matter and light. If so, then what we're seeing may not be a frozen past structure. It could be an active process still ongoing, a form of cosmic erosion. And if it's expanding, then where does it cease? Or does it ever end at all? Now picture this for a second. Billions of years from now, our own galaxy could be the victim of this effect. Our stars could disappear one by one, not through death or aging but through erasure. Erased clean by some unseen force gliding silently through the universe. If it sounds like the script for a frightening sci-fi film, that's because it is. But now, researchers are finding out that truth can't be quite so different after all. And unlike fiction this time, there's evidence. To meet all this, NASA, ESA, and other international agencies already have follow-up missions in the works. Not only with Webb, but also with future telescopes such as the Nancy Grace Roman Observatory and potentially even next-generation cosmic probes. There's discussion about scanning similar areas more intensely, of looking at old Hubble data again and comparing it with what Webb observes. Some scientists are even urging a reconsideration of the lambda-CDM model, the reigning standard model of cosmology. If this emptiness doesn't fit that model, then the model must adapt. Meanwhile, Webb will continue to observe. With each new photo, we are one step nearer to comprehending this weird and old-timey anomaly. And it's accomplishing this with technology that is almost magical. Consider this. This telescope, standing 1,000,000 miles from Earth at the L2 Lagrange point, is so sensitive it can sense the warmth signature of a bumblebee on the moon. That's how potent it is. It's like wearing glasses for the first time and noticing just how out of focus your eyes were before. That's what Webb is doing for the whole field of astronomy. And let's not forget how quickly this all occurred. James Webb has only been operational since 2022. Within a few years, it has utterly transformed our understanding of the early universe. Not incrementally, abruptly. Like a floodlight being turned on in a dark room. We're no longer speculating in the dark. We're looking at the universe as it actually is. And the truth is, it's stranger, emptier, and more melodramatic than we ever dared to imagine. So what do we do next? The next few steps are important. We must examine more areas, determine if this emptiness is an anomaly or a part of a larger trend. We must create more robust simulations, develop more sophisticated theories, and perhaps come to accept that the Big Bang was not the tidy, neat explosion we always thought. Perhaps the early universe was chaotic, disorganized, and riddled with weird, unexplained structures. Perhaps our present-day physics is only one chapter in a much larger cosmic narrative. And perhaps, we've been posing the wrong questions all these years. Not what caused the Big Bang but what preceded it. Because this emptiness, this quiet observer at the limit of existence, could be whispering secrets from before time. A latent fingerprint left by forces prior to our universe. And we're only now emptier and more melodramatic than we ever dared to imagine. So what do we do next? The next few steps are important. We must examine more areas, determine if this emptiness is an anomaly or a part of a larger trend. We must create more robust simulations, develop more sophisticated theories, and perhaps come to accept that the Big Bang was not the tidy, neat explosion we always thought. Perhaps the early universe was chaotic, disorganized, and riddled with weird, unexplained structures. Perhaps our present-day physics is only one chapter in a much larger cosmic narrative. And perhaps, we've been posing the wrong questions all these years. Not what caused the Big Bang but what preceded it. Because this emptiness, this quiet observer at the limit of existence, could be whispering secrets from before time. A latent fingerprint left by forces prior to our universe. And we're only now beginning to hear. So the next time you gaze up at that evening sky and notice the stars twinkling back at you, recall this: they're only the surface. Only the tip of the iceberg. Below them is darkness, deep, old, and full of questions. And with James Webb, finally we are courageous enough to pose them.